Okay, so a discrete probability distribution, that's what we're going to talk about today. A discrete probability distribution consists of all possible values of the discrete random variable along with their associated probabilities. So you guys learned about discrete probability or discrete random variables last class after the test. So we talked about like flipping a coin, you get heads or tails. The discrete random variable with like all the possibilities that you could get when flipping a coin. Now, a discrete probability distribution takes all of those discrete random variables and determines their probabilities. And that's what you get a discrete probability distribution. Now, just a reminder, the sum of all probabilities must equal 1. Okay? The sum of all probabilities must equal 1. And the probability of any given value has to be in between 0 and 1 inclusively. Do you guys remember our number line? 0 was impossible, 1 was certain, 0.5 was 50-50, so on and so forth. Okay? So number 1 says, create a probability distribution for the number of heads observed in 3 tosses of a coin. Okay? So I want you to think about it. We have a coin, we're going to toss it 3 times. We've talked about this example before. They want me to create a probability distribution for tossing a coin 3 times. So we're going to have a T-chart, okay? Over here I'm going to have X, and X is going to represent the number of heads, okay? X is going to represent the number of heads. I'm going to... Okay. Whatever. Then over here, the right side of your T-chart is going to be the probability of it. So you'll see that it's going to be the probability of capital X equals lowercase x. Sometimes it'll just be the probability of X. They mean the same thing. They mean the same thing. It's driving me nuts. Come on. All right. So in our T-chart, we got to think, if we are flipping a coin 3 times, how many possible heads could we get? What's the lowest number of heads that we could get if I'm flipping a coin 3 times? 0. I could get no heads, right? What else could I get? I could get 1 head. What else could I get? 2 heads, and what else could I get? 3 heads, right? Those are my possibilities. I could get 0 head, 1 head, 2 head, 3 head. Goodness. All right? Now, to figure out the probability of that, we have to figure out a couple of things first. First of all, we have to figure out how many possible outcomes are there. So, do you remember when we created the sample space for tossing a coin 3 times, how many possible outcomes were in that sample space? Do you remember? Okay, so let's talk about figuring it out, right? So, how many possibilities are there when you flip 1 coin? 2, heads or tails, right? And how many times am I flipping that coin? So I'm going to take 2 to the 3rd power. And how many outcomes are in that sample space? There's 8 possible outcomes. 8 possible outcomes. Now, while you're taking notes on an Excel sheet, you can always click back on it and see, how did I get that? Like, what did I do? And then, like, so maybe over here you might want to take notes and say 2 to the 3rd power because 2 is the number of outcomes of 1 coin flipped 3 times, okay? So there are 8 possible outcomes. Now, out of those 8 possible outcomes, how many ways could I flip the coin and get 0 heads? 1. What was that outcome? Do you guys remember that sample space? And what I'm talking about is we had heads, 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 tails, heads, tails, heads, heads, tails, tails, heads, heads, oh, no, heads, what am I missing? Get out of here. Tails, heads, heads. Tails, heads, heads, thank you. Tails, heads, tails. Tails, heads, and tails, 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 right? That was my sample space. But, like, what if we had a crap ton? What if it wasn't just 3 flips? What if we had 10 flips or 50 flips? How do I do that without having to sit there and list out the sample space? A combination? So a combination here, how many possible ways could I get 0? That would be combination of 8, choose 0, and what do we get? 1. Okay, so combination of 8, choose 1, right? Combination of 8, choose 2. That's not right. Why am I saying 8? Should be 3, shouldn't it? Because it's 3 tosses. Combination of 3, choose 1. I'm having a rough day today. 3, choose 0. There we go, Mrs. Getz. Combination of 3, choose 1. Combination of 3, choose 2. Combination of 3, choose 3. Where did that 3 come from? Where is the 3 coming from? How many times I'm tossing the coin? Good. So that is literally just like simplifying this. There's only one possible way I can get 0 heads. There's only one possible way I can get 3 heads. There's 3 possible ways I could get 1 out of 3 heads. Does that make sense? But notice I didn't put that in the right side of my t-chart because the right side of my t-chart is the probability. The probability, right? So to get the probability, we want to take the number of times that I can get it and divide it by what? What am I dividing it by? Why 8? Because that's the total amount of outcomes. Very good, the total amount of outcomes. Okay, so the probability of flipping 0 heads is 0.125. The probability of getting 1 of those to be a head is going to be 3 out of 8. So 0.375. The probability of getting 2 would be 3 out of 8. The probability of getting 3 would be 1 out of 8. Are we okay with that? Yeah? Now, if you don't like those as decimals, let me teach you a trick. You can highlight those right there if you don't like those as decimals, and you can come up to your Home tab, and right here there's a little box that says number. There's a little box that says number. You can drop down here and you can click fraction. And there you have a more clear vision of what's really going on. 1 out of 8, 3 out of 8, 3 out of 8, 1 out of 8. Does that make sense? So guys, this right here, that's all that a probability distribution is. That's it. It's what are your possibilities and what is the probability of each of those possibilities. Now, before you move on, we need to check something. In order to be a probability, the sum of all the probabilities must equal 1. So let's add all of those guys together. And if it does not equal 1, we did something wrong. Does it? We're good to go. You highlight them and you go to fraction. Up here in the number box, you go to fraction. Okay. I just added them all together. All right. The next thing we're going to talk about, get out of here. The pin is not working very well. If that just stays there, I'm going to be very annoyed. Okay, now the next thing we're going to talk about is something that you are definitely going to see on your Hawks homework. Okay, you're definitely going to see this on your Hawks homework. Number 2 says, determine if the following are examples of probability distributions. Okay, so they're going to give you an example and they're going to say, can this be a probability distribution or not? Now here's the thing. You're going to have 2 columns or 2 rows depending on how they give it to you. The x value, it does not matter what it is. It does not matter. So this could be a 1, it could be a positive number, it could be a negative number, it could be a fraction, it's whatever. The x values can be whatever. So 1, 2, 3, those are totally fine, that doesn't bother me. It's the probability that we have to focus on, okay? And to determine if it can be a distribution, you have to remember what this reminder says. The sum must equal 1, and the probabilities have to be inclusive between 0 and 1. So if I'm looking down here, first of all, the sum has to equal 1. So if I take these and I add them together. So the sum of this guy plus this guy plus this guy, it doesn't work because it's not reading them as a number. Awesome. So we're just going to do it old school. I'm having a great day today. So if we take 2/3 plus 1/3 plus 4/3, is that going to equal 1? No. So right away, this cannot be a probability distribution because, and my explanation would be 2/3 plus 1/3 plus 4/3 is greater than 1. That can't happen. Okay? This is not a probability distribution. Okay? On part B, again, the x values can be whatever they want. So we have a negative x value, that doesn't matter. X values can be whatever they want. But the probabilities are what our focus is. So if I take 0.25 plus 0.5 plus 0.25, do they equal 1? So that's good. Then I need to focus on each one individually. Is each one of these probabilities individually in between 0 and 1? Yes. So this can be a probability distribution. Okay? This can be a probability distribution. Part C, the x values can be whatever they want, so we're good there. The probabilities, I want you to take a look at them. Do we think this is a probability distribution? No, why not? Yeah, there's a negative value. It doesn't matter that if I add them together, the 0.7, the negative 0.2, and the 0.5, that I do get 1. It doesn't matter. Because one of them is negative, it cannot be a probability distribution. Okay, so let's look at number 3. KJ Johnson is a computer salesperson. During the last year, he has kept records of his computer sales for the last 200 days. Create a probability distribution from the given frequency distribution, then answer the following question. Okay, so we're going to focus on this little table right here. They gave me a frequency distribution. They said there have been 0 days, or 0 sales on a day for 40 days. There's been 1 sale for 20 days, 2 sales for 60. Does that make sense? This is my frequency distribution. To figure out the probability distribution, all we have to do is take the frequency and divide it by the total. So the first thing we're going to do here is we're going to find the sum. We're going to find the sum of all of my frequencies. So you're going to type in equals sum, and you're going to highlight all the numbers you want to add together. What is my sum? 200. Well, here's the thing. We already know that. It tells me here he kept records of his computer sales for the last 200 days, so it should be that. I did that so I could use the number, though. Okay? Now, to find the probability, what we're going to do is we're going to hit equals, and we want to take that frequency and divide it by the total, which was 200. Now, I'm making a formula. The whole purpose of Excel is to make things easier. So I'm going to put an absolute cell reference on that C37 because I don't want it to move when I drag it down. So you should have C32 divided by C37, but make that C37 absolute. And then when you hit enter, you should get 0.2, 0.2. Now, you're going to click on the little green box. You're going to click on the little green box and just drag it down, and it should autofill. Now, to see if we did it correct, the probabilities should all add up to equal what? 1. Check this out. I already have this guy right here. This guy right here takes the sum of all of these. If I click on this little green box and just drag it over, it's automatically going to find the sum of all of these. Did the sum add up to equal 1? So we did it correctly. Now let's answer these questions here. What is the probability that he will sell at least 2 computers each day? We need to improve our reading and comprehension skills a little bit, so can you explain to me what does it mean when it says he will sell at least 2 computers each day? How many would that imply? 2 or more, so we could sell 2, 3, or 4, right? So what they're saying is find the probability that he sold at least, so greater than or equal to, nope, come on, My computer is not liking me today. And if you want to know how I did that, I just underlined the greater than symbol, greater than or equal to 2. Okay, the probability that it's greater than or equal to 2. I underlined the greater than symbol. Look, home. If I go back, just look right here. Look up in here. Probability that it's greater than 2. I just made sure I underlined the greater than symbol. Okay. Goodness. Now, to do this without having to use your calculator, without having to use your brain, here's what we're going to do. We're going to hit equals, sum, and I am going to add all of the probabilities of 2 and more. So that would be 0.3, 0.2, and 0.2, those 3 guys right there. So what's the probability that he will sell at least 2 computers each day? 0.7. Now for part B, what's the probability that he will sell at most 2 computers each day? What does at most 2 computers each day mean? 0, 1, and 2 or not? Yeah, that would count. So that's going to be the probability that it's going to be less than or equal to 2. So that's going to be the sum of 0, 1, and 2's probabilities. Now here's the thing, guys. If this right here freaks you out, don't panic. Like, you can always just write it out, probability of greater than or equal to 2, and the probability of less than or equal to 2. Like, it's just a method of taking notes. You're labeling what the heck you're finding so you know how to find it later. Okay? All right. Now, the next thing we're going to talk about is expected value. Okay? The expected value is denoted by mu. Have we seen mu before? What does mu mean in the past? Population mean, right? Well, the thing is, mu and expected value are very, very similar. That's why we're using the same symbol. Mu, which also can be referred to as capital E of x, which would represent expected value, is found by taking the sum of each value times its probability. Okay? Now, the expected value can be used as criterion for comparing alternative decisions in the presence of uncertainty. So here's the thing. When you guys hear the words expected value, your brain immediately goes to the place where it's like, this is what I'm expected to find. This is what we expect to happen. But that's not what the expected value is. The expected value is not the value of a random variable that we expect to see. Instead, it's closely compared to the average of the values. That's why expected value has the symbol of mu, because it's very, very close to the average. So here's how we're going to find it. Okay? Using our table from number 3, so this is the table that we just found, and I made our probabilities red. We want to find the expected value. Again, the formula to find the expected value is given in this little box right here. The formula is the sum of each expected value times the probability. So if I want to work this formula out, I have to kind of work backwards. I have to start on the inside and then work my way out. So the first thing I need to do is take each value and multiply it by its probability. So on our table here, I created a column for that. I want to take each expected value and multiply it by its own probability. So here, I'm going to come in this box and I'm going to hit equals. I want to multiply the expected value, which is going to come over here, and that's going to be 0. And I want to multiply it by its probability, which was 0.2. Notice I'm not just typing in 0 times 0.2. Like, that's not what I'm wanting, because I want to create a formula to make it easier. So once I hit equals, we know it should be 0. I want to hover over the green box until my mouse becomes a plus sign, and I want to drag it down and fill it in. Okay, I want to drag it down and fill it in. So what that's done is that's taken care of this guy right here. Okay, we've found each value times its probability. Now what we need to do is we need to find the sum of all of those. So I'm just going to come down here, and I'm going to type in equals sum, and I want to add all of those together. Those should not equal 1. They can, like it can happen, but it's not, it doesn't have to. This is not the probability. This is the expected value times the probability. So we should get 2.1 there, okay? That is the sum of each expected value times the probability. All right? Now let's talk about what that means. If the expected value is 2.1, what does that mean? Okay? Well, the expected value is very, very close to the mean. So here's what it means. That means that in the long run, thank you, KJ Johnson will average 2.1 sales per day. Okay? Yikes. Now, if you typed that into a cell and it did that and you're like, I hate that, no big deal. You're going to just highlight the cells that follow it. I don't care how many. You can highlight to J or K, whatever. And you are going to come up here and click on Merge in Center. It's in the alignment box, and it just merges them so it can spread out a little bit. Now, it still looks gross, so just come over here to the row where it's 55, and you can come down here and just double-click it, and it'll readjust. Now it's smashed, which sucks. So I'm just going to highlight the row below it and merge and center it again so that it is a little easier to read. Okay? Now that's optional. It's just a way to take notes. Okay? So the expected value is each individual value times its probability, and it's the sum of all of those. So in the long run, KJ Johnson will average 2.1 sales per day. Does that mean that he's going to have 2.1 sales per day? No, you can't even have 0.1 sales per day. That's saying after a long time, in the long run, that's going to be his average. Okay, so let's go to number 4. Suppose you are confronted with two investment alternatives that possess uncertain outcomes described by the probability distributions in the tables below. In the long run, which plan will have the higher payout? So here's what this means. There's plan A. You're investing. There's a 0.2% chance that you could lose $2,000 out of this investment. Does that make sense? There's a 0.1% or there's a 0.1 probability that you're going to break even. You're not going to make any money out of this investment. There's a 0.3 probability that you could make $1,000 out of this investment. Do you understand how this table reads? So you're investing the money. There's plan A on the left, there's plan B on the right. Okay? I want to know, in the long run, which plan is going to have the higher payout. So to figure that out, we need to find the expected value. So here's what I'm going to do. For plan A, I'm going to find the expected value. So I'm going to add a column here, and to add a column, you're not really doing anything. You're just clicking next to it. And this column needs a header so you know what you're doing. So in this column, we're going to take X times P of X. Now just a reminder, P of X is interchangeable with P of X equals X. They both just mean probability. So in this problem right here, what I'm going to do is I'm going to take equals the payout times the probability. We're just going to drag it on down. Just like we did on the last one. What am I going to do down here? We're going to find the sum. That is my mu. That is my expected value. And I'm going to highlight it just so it's easy for me to see. You don't have to. It's just so it's easy for me to see. So the expected value in the long run, this plan pays out on average $900. Okay? Let's do the same thing for plan B. I'm going to take x times p of x, and I want this guy times this guy. Drag it down. In the long run, how much does plan B pay out? $1,400. Okay? So what we've done is we just found the expected value for each plan. Now the question says, in the long run, which plan will have the higher payout? Now, earlier up here, we typed our answer and then we merged in center, and sometimes that freaks people out because they're like, it really messed up my layout. Okay, well, we know we need to type an answer, so what if we do this? Select the area where you want to put your answer. Notice I selected rows and columns. I selected a little box. That's where I want my answer, right? I'm just going to highlight those, and I'm going to merge and center them first. Then it doesn't mess up the layout after I type. So which plan will have the higher payout? Plan B will have the higher payout, and then I always make sure I say in the long run. Now, if you'll notice, like, I can't see all of my words. That's super annoying. You could either extend the area that you want to merge and center, or come up here, and there's a little button right here that says wrap text. It says A, B, and then it has a little arrow and it says C. Click that, and it'll make it like a normal sentence. Okay? I use these two buttons a lot. A lot. The wrap text and the merge and center. Okay. Now, while option B has a greater expected value, which means in the long run it has the greater expected payoff, it seems to have the greater risk than option A. Let's look at what they mean. So if you look, you have a 0.2 probability of losing $3,000, a 0.1 probability of losing $1,000. This one only had one possibility of losing $2,000 of losing money. This one has two possibilities, right? So that's where the greater risk comes from. Option B offers a greater chance of making a substantial, goodness gracious. Option B offers a greater chance of making a substantial gain, but it also has the potential for significant loss as well. This is where it's important to remember that the expected value is just one measure. It's just one number that people can look at, okay? Now, to gauge the variability of a random variable, we should look at the variance of each random variable. This variance will be different than what we learned in Unit 1, as it accounts for difference in probabilities of the variable. So this is variance. We talked about this in Unit 1, but it's going to be a little bit different because it's going to account for the difference in the probabilities. All right? It's not just going to be focused on the mean. It's going to be difference of the probabilities. So Plan B has the greater payout, but we're going to see if it really does have a higher risk. So the larger the variance, the more variability in the outcomes. We should understand this by now. So here are the formulas that we're going to use. We have the variance of a discrete random variable, and it's given by this formula right here. Okay? Variance is sigma squared, also known as V of x, and it looks like this long guy right here. Standard deviation is literally just the square root of it, right? Are we okay with that? Now, let's find the variance and standard deviation for both plans from above. So I already have the tables down here for you, but I want to talk to you about how we're really going to dissect this formula. This is the formula that we know we have to figure out. This is what we're finding, okay? Again, I'm starting inside of the formula and working my way out. According to the order of operations, we start with grouping symbols, right? So I have grouping symbols here and here, right? So I'm going to start on the inside of those. Then I have parentheses here and I have parentheses here. Isn't it pretty obvious that these parentheses are not really doing anything? It's not like anything inside of it. It's just a probability. So I'm going to focus here. I want to start with finding each value and subtracting my mean or expected value. So I'm going to come down here. We need to find the expected value, which we technically already did, but we're going to have to do it again. So we're going to find the expected value here. We're going to take this guy times this guy. Drag it on down. And how do I find that expected value? Yeah, equals sum. That's my mu. That's my mean. And again, I'm going to highlight that because I know that I'm going to need it. I know that I'm going to use it. So according to this formula, I need to take each value and subtract my expected value. So here's my expected value down here. So I'm going to go equals, and I want this guy minus my mu. So what should I do to that mu? Because is that going to change? No, so we want an absolute cell reference on that. Then we're just going to drag it down. Then, according to my formula, so I took the expected value and subtracted my mu, I have to square that. I have to square each of those values. Notice I didn't take the sum yet because the sum happens at the very end. This whole thing is in brackets. The sum doesn't happen until the very end. So I want each one of those values that I just found, and I want to square them. So that's going to be my next column. So I'm going to say equals, and I want that value that I just found raised to the second power. That value that I just found raised to the second power. Then we're going to autofill that. Now, some people freak out because they're like, what just happened? Oh. Ah! I don't know what happened either. That's so bizarre. So for some reason that text box like copy and pasted, so just click on the text box and delete them. I'm sorry that that happened. Some people freak out though. While you guys are doing that, I'll talk. Some people freak out because they're like, Mrs. Getz, these numbers are really, really big. Well, yeah. I mean, look at the numbers that you're squaring. 2,900, you have to square that. Those numbers are going to be huge, and that's okay. Okay? I don't know where those text boxes came from. Oh. Okay. Now, according to my formula, I have each expected value minus the actual expected value, and I squared them. Now I need to multiply them all by the probability. So that's going to be my next column. So I'm going to say equals, and I want that squared value, and I'm going to multiply it by its corresponding probability. Multiply it by its corresponding probability. Then you can click and you can drag that down. Why? Oh, that's so annoying. I wonder if it does that if I go the opposite direction. Try it on the next one. Okay. Once I have all of these things fulfilled, I found my mu, I subtracted it, I squared it, and multiplied it by the probability. I satisfied everything inside of that. Now I find the sum of it. So what I'm going to do is you can either find the sum down here. I know that finding the sum is going to give me the variance, so I'm going to come over here. And I'm going to find the sum over here because that's going to be my answer. So I'm going to hit equals sum. And I'm going to highlight all of those values that I just found. So that's going to be your variance, 3,090,000. What did it do? Okay. Yeah, they're walking around on the roof. Sorry. Okay, now how do I find the standard deviation? Square root. I don't even have to do any other formulas, just SQRT of that variance. Now, quick question, like, what are we talking about? Money? So, like, this is not a good answer for our money because, like, 1757.8396. Can we change that to actual money? Come over here. You can either click the currency symbol, that would work, or like if you just want to move your decimal, I'm just going to click the currency symbol and it'll change it into money. Okay? Okay, so here's what I want you to do. I walked you through the process. For Plan B, you're going to walk through the process again. With your table partner, I want you to fill out the table, find the variance and the standard deviation for Plan B. So, when you work with Plan B, you should get a variance of $6,640,000 and a standard deviation of $2,576.82. So, comparing the two variances, which one has more variance? Which one has more risk? Plan A or Plan B? Plan B has the higher variance, so it has the higher risk. So yes, in the long run, it would have the higher payout, but it also has the greater risk. So when you are making investments, you have to think logically. Am I able to continue to invest enough money to keep this going to get the high payout? Or is it going to be a short-term investment and I don't want to risk it? Does that make sense? So, a larger standard deviation reflects greater variability in profits and increased risk. That makes sense, just like a larger variance does. If the standard deviation is just the square root of the variation, the bigger standard deviation also means the greater risk. When variance is considered, the decision becomes more difficult. Here, the option with the largest expected value is also the option with the greatest risk. So let's go to number 5. It says, consider the following data. Okay, so I have all of my random variables here, 4, 5, 6, 7, and 8, and I have all of their probabilities. Then there's letter A, B, C, D, and E that they want me to find. And it says, find the expected value round to the nearest tenth. Well, here's what's annoying. This table right here is not how we like our tables. We like our tables like to have columns instead of rows, right? So I'm going to show you how to fix that. Because you can do it this way, it's just weirder. So when you copy data from Hawks, a lot of times it's going to give it to you like this. So here's what I want you to do. I want you to highlight the whole table. And you're going to copy it. So Control C. Then I'm just going to put it right here in I-124, okay? I'm just going to click on that cell. Do not paste it yet. You're going to come up here to where it says paste. Look up here on the home. And you see how there's like a little drop-down arrow? I want you to click that drop-down arrow. And you're going to come all the way down to the bottom and you're going to click on Paste Special. And it's going to pop up this little dialog box, which is really nice. And you're going to come down here and click on Transpose. What that's going to do is that's going to take your table from going left to right and transpose it so it's going up and down. Click OK, and look, just like our table wants, or we like it to be. All right? So now what we're going to do is we're going to find the expected value. So remember, the expected value is just going to be each random variable times its probability. Okay, each random variable times its probability. So we're going to hit equals, take your random variable times its probability, and drag it on down. Now what do I do with it? We find the sum of it. Very good. Now I'm going to show you another neat little trick here. Letter A wants me to find the expected value. I found it over here. You could have found it over here. That would have worked. That would have been no problem. But watch what I'm going to do instead. This is where I want my answer. Sure, fine. I'm going to hit equal. And I just want you to click on the cell with the answer. That's 6.2. And then hit enter. And it'll take your answer right up there. So that way, if like you make changes, it'll change your answer as well. Cool? So be careful with that. But yes, that's what it will do. Next, it wants me to find the variance and round to the nearest tenth. So to find the variance, we have to use this formula right up here. Okay, we have to use this formula right up here. So when you are using that formula, I'm going to write it down so we can dissect it. We're going to take it one piece of information at a time. Okay, so the formula says the sum of each random variable times its probability, or nope, excuse me, I'm reading the wrong one. Each random variable minus mu quantity squared times probability. Okay, that's our variance. So we need to break it apart one piece of the formula at a time. So we start all the way on the inside. We found our mu. Now we want each random variable to subtract it. So I'm going to have here, this one's going to be x minus mu. So I want my random variable minus mu. And again, I don't want that to change, so absolute cell reference. What do I do with that value then? We square it. So I want x minus mu squared. Once I've squared them all, what do I do with them then? Multiply it by p of x. So I'm going to have x minus mu squared times p of x times my probability. So I want this one times this one. Well, then what do I do? Find the sum. Very good. Now, when you have a table like this and you just have numbers at the bottom, sometimes it's really hard to see what they are. So I always go ahead and label. I say this is my mu, this is my variance. Now, my variance is 2.36, so you can come over here and you can say equals my variance. And then to find the standard deviation, I don't even need to go back to the table. First and foremost, here is what you do not do. You do not just come over here and go SQRT of, and then type in 2.36. Do not do that. Why don't we do that? Yeah, we don't know if that's really the answer. Maybe it was rounded and we don't know it. So you always take the square root of the cell. You do not take the square root and type in a number. You always take it of the cell. Because if it's longer, for example, if I come and click on this, what if it's not just 2.36? What if I make the decimals go further? Here we're lucky, but what if it was 2.36149 and I just didn't know it? So always do the cell reference. So that's the standard deviation. And then for part D, it wants me to find the value that the probability of our random variable is going to be less than 7. For that, we're going to go back to our original table. You can go to this one up here, but we're just going to focus here. The probability that it's going to be less than 7 would be these three guys together, right? So we're just going to find the sum of these three guys. And we should get 0.5. Now to find the probability of it being greater than or equal to 7, we do the sum of 7 and 8. There it is. On C, I took the square root of the variance. Now number 6, if you throw exactly 2 heads in 3 tosses of a coin, you're going to win $36. If not, you're going to lose $27. So I'm coming to you and I say, hey, I'm going to make you a deal. I'm going to give you a coin and you're going to toss it 3 times. If you toss exactly 2 heads, I'm going to give you $36. If not, you have to pay me $27. So what we want to know, is that a good deal? Do you think you're going to win? Do you think you're going to come out ahead? So Part A says, find the expected value of the proposition. Round your answer to the nearest cent. Losses should be expressed as a negative value. So what I've done is I've given you a little table. Whenever you're given a problem like this, you want to express it as a table. This is a probability. So if you throw exactly 2 heads in 3 tosses of a coin, you're going to win $36. If not, you're going to lose $27. So you have 2 options. You can either win or you can lose. If you win, how much do you get? $36. If you lose, how much do you lose? So that's going to be a negative $27, okay? Next, what we have to do is figure out the probability of you winning and the probability of you losing. So what we have to do is we have to think of some options here. First of all, we have to think like, how do we find that probability? So how many total tosses do we get? 3 total tosses, right? So total tosses is 3, okay? Now the total outcomes, don't you remember how we do that? There were 2 possibilities, and we're tossing it 3 times. So the total outcomes would be 8. There were 8 total outcomes. And if you win, how many heads do you have to toss? Okay, so we want to get 2 heads. So that is going to be 3 choose 2. Okay? Combination 3 choose 2. What do you get combination 3 choose 2? 3. So there are 3 possible ways that you could only toss 2 heads. Okay? So the probability of winning is going to be how many you want, which is 3, out of how many possibilities, which is 8. Are we okay with that? Now, the probability of you losing is whatever is opposite of that. It's the complement of that. So the probability of you losing is going to be however many left. So you could do one of 2 things. If there were 3 ways that you could win out of 8, how many ways could you lose out of 8? 5. Or you could just come here and you could go equals 1 minus, and you could click that cell, because it's going to be whatever's left. So right now, just by looking at this table, do you have a higher chance of winning or losing? Losing. Yes, sir. Now the question didn't just want you to make this table. The question said find the expected value of the proposition. Find what is expected to happen if you play this over and over and over and over. So the next column we're going to have to make is x times probability of x. Like that's the expected value. Take each one of your random variables and multiply it by the probability. So boom times boom. But what do I do with those? Sum them up. Very good. Now be careful, because part A did say find the expected value, but it said round your answer to the nearest cent. We did have a lot of issues with reading those directions on the test. I had a lot of people say, how are we supposed to round this, when it said write in the instructions. Round your answer to the nearest cent. Losses should be expressed as a negative value. So my answer here is negative 3.375. I want it as a, I clicked currency right here, just click the currency, and notice how it puts it in parentheses? That means that it's negative. When you're dealing in currency and they put parentheses around it, that means it's a negative value. Okay? Now, if you played this game 623 times, how much would you expect to win or lose? First of all, are we going to win money or are we going to lose money? We're going to lose money. This game is not set up for you to win. So we're going to hit equals 623 times, and I just want you to click on your expected value, the cell. So, are we going to win money or lose money here? Lose money. How much are we going to lose? Woo! $2,102.63. Let me tell you guys, I have a game that I would like to play with you. The odds are great in your favor, but I would like to play it 623 times. Okay. All right. The last thing we're going to talk about is the discrete uniform distribution. So we just talked about probability distributions for random variables, okay? We had to find their probabilities. We had to create the functions. We had to create the tables. Now, the discrete uniform distribution is one of the simplest probability distributions because each value of the random variable is assigned identical probabilities. Okay, so a good example of this would be rolling a die. Every option is the same. Every option has the same probability. So, number 7, what is the probability distribution for the outcome of the throw of a single 6-sided die? So, we're going to create a probability distribution. We're going to have x, and we're going to have p of x. Okay, x and p of x. Now let's talk about what x represents. If I'm rolling a die, what are my possible outcomes? 1, 2, 3, 4, 5, 6. Now, the probability for rolling each one of those, what's the probability of rolling a 1? 1 out of 6. What's the probability of rolling a 2? 1 out of 6. What's the probability of rolling a 3? 1 out of 6. What's the probability of rolling a 4? What's the probability of rolling a 5? What's the probability of rolling a 6? Now that's a weird number. I'm going to change those to fractions because that just makes more sense. Yes, sir. Yeah, highlight them all. Come up here, drop it down. Click on fraction. There you go. Okay. So that's the only difference between a discrete uniform distribution and a discrete probability distribution. The only difference is all of the probabilities are the same. That's it. That's all 7.3 is. All the probabilities are the same. So on number 8, suppose a purchasing agent has just received a pricing and delivery schedule from a new vendor. The delivery is scheduled, was quoted as 1 to 4 weeks. The purchasing agent wishes to construct a probability for the time until delivery. So we're going to create a table, and we're going to have the random variable, and we're going to have the probability of it. So the delivery schedule was quoted as 1 to 4 weeks. So the delivery could get here in 1 week, it could get here in 2 weeks, it could get here in 3 weeks, it could get here in 4 weeks. We don't know. Now the probability of each week is not different from the other. So the probability of it getting here on week 1 would be 1 out of 4. Week 2 would be 1 out of 4. Week 3 would be 1 out of 4. Week 4 would be 1 out of 4. All of those probabilities are the same. And that's where we get the discrete uniform distribution. They all have the same probabilities.